It's been an interesting year for SETI with multiple new detections coming out, and now there are even more after a second pass of the data. But again, it's only potential ones, probably not, ultimately. But these are the best from a decades-long SETI endeavor, but best does not mean unambiguous. Many here will remember in 1999 and through the 2000s, there was a project called SETI at Home, where the interested could download a screensaver for their computer, and instead of the computer being idle, it would use its extra processing ability to work through the absolute mountain of SETI data that exists from radio telescope observations of the time for promising signals of unknown origin. This project actually continued until 2020, but after a point ran on a different platform than the original that wasn't as accessible as the old system had been. A project of the University of California, Berkeley SETI Research Center, the project was widely popular among people interested in helping within the search for alien life. It had 5.2 million users at one point, when it was expected to only have 50,000 participants. But it also was popular with people just looking for a useful, neat screensaver or background program using extra processing power that wasn't just an attractive thing that the computer did when idle, but instead moonlighting as a scientific computer, doing real citizen science and making itself useful when not in use. Indeed, entire companies were using this screensaver on all the machines in their offices, sometimes controversially. People were fired for illicitly running it in some cases. The data were mostly collected by the Green Bank and Arecibo telescopes through piggybacking. While the telescopes were doing astronomical observations, there was a SETI instrument also mounted that was taking serendipitous observations in tandem to whatever the telescope was observing. That was a good strategy, but it made for a lot of data. But from an ocean of data ultimately came a mountain of data processing, because even after all the processing at the time, this was the largest computing operation ever done by some estimates, still came up with 12 billion candidate signals. This meant that the SETI at Home team at Berkeley had to use algorithms to pick out the very best candidates, and initially they found no conclusive candidates. No slam dunk it's aliens moments happened with that project. But there was a concern that maybe the bar had been set too high during the first pass, and that the scientists were at risk of throwing the baby out with the bathwater and may have missed more subtle signals that could be of alien origin in the process. It's worth noting, however, that the key word here was conclusive. While there were no signals pulsing out prime numbers or anything obvious, there was a little-known signal that, to this day, remains mysterious, because unlike most SETI signals, this one actually repeated it. Known as SHGB02+14A, the signal actually comes in second to the WOW signal as far as stronger candidates, but due to the unwieldy star catalog designation did not stick in the public mind and today is largely forgotten. It was discovered in March of 2003 by SETI at Home using data from the Arecibo telescope in Puerto Rico. It was observed 3 times, repeating for a total of all observations being about 1 minute. In frequency, it was at the famous 1420 MHz line of the waterhole region of the radio spectrum. This is where the neutral hydrogen in the universe emits in radio, but does so broadband because hydrogen is in motion and thus red and blue shifting, that making it broadband overall. This is of course thought to be a good place to look for aliens broadcasting to other aliens, because if you can build a radio telescope, you have the science to know about this frequency, and would realize it's universal to anyone with radio astronomy, and it becomes a natural place to broadcast at, rather than randomly on the dial if your intent is to get attention. The idea past that is that once you see the tone at 1420, call it a dial tone, you know to look around that area for signals that actually do contain complex information, which might even be more broadband. But the initial dial tone is very narrowband, screaming technology, in an area of the radio spectrum that should not have such a signal, and your actual information signal can be located in the area of the spectrum around that, which admittedly comes with its own problems, but at least the whole idea provides a place to look in a radio spectrum of many millions of frequencies. I'll say it here, it's possible that this particular signal might have been an example of throwing the baby out with the bathwater, and it might have been a better signal than it was originally given credit for. The source of the signal in the sky was between the constellations Pisces and Aries. This particular area, though, is not very populated with stars within 1,000 light years of Earth. There just aren't many close stars in this direction. That led to skepticism, but who is to say that it wasn't a deep space station or ship, or a more powerful but distant signal? There is a bias in radio SETI for planets, not spacecraft, because planets seem the low-hanging fruit. The second point of skepticism was that the signal very rapidly drifted in frequency, between 8 and 37 Hz per second. It's unclear what would cause that. You can't actually tell what is causing this kind of shifting from the signal, but one possibility is that it was in fact redshift, and would indicate that the source, if it were a planet, rotates 40 times faster on its axis than the Earth does. Again, that does not seem too likely for an inhabited planet, but look at our spacecraft. They often spin, and there are reasons to do that, such as approximating gravity through centrifugal force. Another problem was that the signal was incredibly weak, but that should probably not be a point of skepticism because an alien signal could and probably should be expected to be very weak. But then there was another oddity. Each of the 3 times the signal was detected, it started at 1420 MHz and then drifted. But it always started at the same frequency each time it was picked up. There's a solid reason to be skeptical of that, and that is not something you would expect from an alien signal. Rather, it almost seemed like noise, perhaps in the receiver, though it never did it again, and that effectively rendered this particular candidate forever an ambiguous mystery. There's just no way an alien is very likely to intentionally make their contact signal ambiguous by matching its drift with the rotation of the Earth. It was ultimately decided it must be an artifact of random chance, whatever that means, some kind of noise from space or a glitch in the receiver that never happened again. But it was a narrowband signal at the right frequency that was repeating, putting it in the same class as WOW, which oddly enough, one point of skepticism that the WOW signal got was that it was too strong of a signal, the opposite argument. Too weak, too strong. Not hard to throw the baby out if you have the goalposts that wide as your criteria. And when I say this area is devoid of stars, there is a caveat there. And more importantly, new information on this star that came out long after this signal was initially discounted. The star is known as TZ Erytis, and it's in the right area. It's a red dwarf, but a rambunctious one, and flares a lot. In fact, it's not visible to the naked eye, but if it flares enough, it gets close to it. It's also very close, just 14.6 light years away. This star was discounted because of the flaring and being too close. It's statistically not likely that the next civilization over from you is on your doorstep. But that only works if there isn't a galaxy-spanning empire of von Neumann probes in all star systems of the Milky Way all transmitting. However, this star has subsequently been found to host at least 2 exoplanets. This highlights, hopefully, the problem with SETI searches. Sometimes you can lay misguided skepticism onto such an extent that it influences your basic searching. And that is what the new re-examination of the SETI at Home data was about. Scientists have better programs and tools to take a look again at the data and search for signals that may have been missed or prematurely discounted, and the results have recently come out, and it yielded 100 new candidates. For those curious, SETI at Home looked for 5 things that hopefully would get past signals that are just noise and human interference. It's worth noting that while the radio spectrum is very noisy both from our satellite downlinks but also the universe itself, the 1420 MHz area is a bit noisy from nature, but set aside for astronomy by international agreement from our technology. So no one is supposed to broadcast there. And not just for SETI, but for observing the hydrogen clouds of the Milky Way for astronomy in general. That doesn't mean someone can't clandestinely transmit there, they just aren't supposed to. So the human interference should be low. The screensaver software looked for spikes in the power levels of the signals. One really important one here is known as a Gaussian, which you might remember from the screensaver if you worked with it. All this is a bell curve. You see it here with the WOW signal. This indicates a point fixed in space. So as the telescope moves past, the signal rises and falls, telling you that you're not looking at something that is moving, like a satellite or aircraft might. It also looked for triplets, where the power spikes 3 times in a row, pulsing, and so on. These are all tricks because radio signals get somewhat garbled in traveling across the interstellar medium, an effect known as scintillation. so these methods help alleviate that effect. Scintillation is just distortion of electromagnetic waves. Whenever you go out and see the stars twinkling in the night sky, what you're seeing is scintillation, due to the Earth's atmosphere moving around through upper atmosphere winds. The interstellar medium and pretty much any medium with material in it can do this, but it causes problems for SETI and can actually be so bad at vast distances of interstellar space to the point that if we did get an alien signal, we might never be able to prove it's technological. But it causes problems for SETI and can actually be so bad at the vast distances of interstellar space to the point that if we did get an alien signal, we might be able to prove it's technological, but never be able to decode it because it's just too noisy from the interstellar medium. And likewise, our signals might be as well. That is a growing concern in SETI circles. But anyway, the new work is a culmination of a 10-year effort to winnow down all of the potential candidates to a list of the 100 best ones from SETI at Home. This has now been accomplished, and the 100 candidates are now set for a second look using China's 500-meter fast radio telescope. China's actively getting into the SETI game with FAST, mainly to see if any of these signals are repeating and can be seen a second time, the gold standard first step for a radio signal in SETI. These observations started in July, but the analysis is not yet complete as far as published papers. Another thing SETI at Home users may remember from the screensaver are the words fast Fourier transform, which was prominently on the screen back in the day when it was running. This breaks down the radio frequencies into sections, bins, something which goes back to the early days of SETI. In fact, the WOW signal had 50 bins or channels. Today, that is many millions of channels for modern radio telescopes, and the WOW signal only appeared in one, which meant that it was very narrow band. It wasn't bleeding across the dial and was just limited to a 10 kHz range, very tiny. Earth, however, is moving, and the source of the signal very likely would be as well, no matter what it is. So by using this transform technique, a program could be written to examine that Doppler shift with SETI at Home, looking at all possible drift rates, something the computing power of the SETI at Home project had with everyone's machines running the screensaver. They could sift and look for interesting Doppler shifting effects that looked like artificial signals coming from other exoplanets. There are a lot of combinations though, and that's where there was still work to be done, because again, there were 12 billion interesting signals the home computers found in this regard. So further analysis has reduced it down to the 100 best ones that FAST is now looking at. FAST is observing each of them for 15 minutes, and it's worth noting here that FAST is huge. It's larger than the old Arecibo dish that collapsed, and it can be difficult to get SETI work done on radio telescopes globally. We shall see if anything interesting comes of it, but very likely this will be more of the same. Interesting signals, but ambiguous, and not answering the "are we alone" question. Any that would have really stood out probably would have done so the first time around with SETI at Home, again ambiguity. But at least it's worth a second look. We shall see. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently getting over some kind of flu or something that knocked me down for a bit. I'm very much ready for spring, though it has not sprung here quite yet. Garden seedlings are moving along though, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.